basically what we have here, signal conversion. So we know, I think it's better to do like that. So we are dealing with some process, and we know that basically in our process, if our process works well, so we don't have some troubles. Our temperature will change from -5 to 140 degrees Celsius. So in that case, first of all, as an engineer, we have questioned what kind of sensor should be used. So basically, we have found that in our warehouse we have sensors which provide information from the or which working range is from -50 to 150 degrees. So basically, we can use those sensors in order to detect temperature and we can use it because first of all we should check that the span of our sensor will be greater than the range which is used by the process. So for example, we are using some RTD type sensor and inside our sensor, inside the head of the sensor, we are having converter which converts this temperature to the signal from 4 milliamperes to 20 milliamperes. So first of all, what we have no, we are starting from temperature. So -50 degrees Celsius, 150 degrees Celsius. Then the second range we will have from 4 milliamperes to 20 milliamperes. This range is the same. And in industry, different types of PLCs are used. So basically, as you could see, for example, we are using ABBs, and there we can choose quite a great range of signals which can be provided to our PLC. So it depends on the input-output module of the PLC. But if we are dealing with small PLCs, which are supposed to be used, for example, in some building automation and so on, they are a little bit cheaper, and sometimes input-output modules, they have just one range. And for example, in this case, we just have possibility that input of our PLC can be changed from 0 to 20 milliamperes. So in that case, we have such a situation that we will send signal from 4 to 20 milliamperes, but actual signal of our PLC is still from 0 milliamperes to 20 milliamperes. So in that case, as you also, if you started to do your homework, you have seen that every input, every analog input, it has its own range which can be provided in PLC, because PLCs basically they are dealing with integer values. Of course, they can calculate real values and so on, but basically we are dealing with integer values. So we have a range. For example, for ABB, it was from 27,648, I guess, I don't remember exactly, it should be checked. But for some of them, they used a little bit less memory. So in our case here, we have that according to the such input module, for 0 milliamperes we will have 0, and for 20 milliamperes we will have 4095. This is the number, this is current, and this is temperature. So basically what we have in our process, first of all, we have our process with some temperature, and after that we are trying to measure this process with our sensor. And on the output of our sensor, we are using signal from 4 to 20 milliamperes. Then we provide this signal to the PLC, and input of the PLC is from 0 to 20 milliamperes. And after then, it's this information is gathered. Basically, we can provide it further to the operator station, workstation, and operator, he or she would like to see information not in some strange integer values, but it would like to see information in degrees Celsius. So basically, this information, those numbers should be converted to the temperature again. So basically, we have several conversions of the same signal in order to provide it a right way to the final to the operator. So our question is, provide equation how temperature depends on the number, basically that n. That means how temperature depends on the number which were obtained by the PLC, and what is the minimum and maximum values for the current process. So we know that our process is okay. It's just half. So this is 0, 50, 100 degrees. In that case, our process and what's those? Okay, something like that. So our process or information which will send to the workstation will be actually from -5 from this point and till that point. But we should find out what is we should convert this information every time. So first of all, let's take a look what we have here. First of all, then we talk about temperature range. Our range will be from 150 degrees Celsius minus 50. It's minimum. So our range is 200 degrees Celsius. This is first what we have here. So our current range is 20 milliamperes minus 4 milliamperes equals 16 milliamperes. So please don't forget about that. But we have some shifts around 0. So basically, let's think logically. So we have one range from 16 milliamperes, which corresponds to 200 degrees Celsius. So in that case, because we would like to get to know what will be the current, so for the current, we can say set it as x milliamperes, and here will be our temperature. So for example, 1 degree Celsius. So in that case, in order to find out x, we should multiply 16 milliamperes by the temperature and divide it by 200. So in that case, probably we could find something, but in that case we have a problem, because currently the maximum value what we will have here, it will be 16 milliamperes, but our value is 20 milliamperes. So in that case, our signal should be shifted somehow. So that basically means that we should know in this case for 0 degrees Celsius what value we will have. So in that case, currently it can be easily calculated or can be easily found. So because we in this case we know that it's just 1/4 of the whole range.
7.5.
So in this case, for 0 degrees Celsius, we will have just 1/4. So basically, it will be plus 4 milliamperes here, with initial value which we have 4 milliamperes. So we can have 8 milliamperes because to 0 degrees Celsius we have 8 milliamperes. But okay, so in this case we can find out what will be the minimal current value, and it's good because actually with that we can check our calculation. So it's just how thinking logically we can obtain that formula. But I know, I have seen it several times. Then you talk to the engineer, basically they don't just calculate like this. They have all their formulas in their files. So, and if they would like to convert one unit to another, they just wait a minute. I should take a look. Okay, I have that equation. So if we obtain that equation, basically what we have, how we can describe it? We can describe it like that. So we will have our maximal value of the current minus minimal value of the current. Here we obtain our 16 milliamperes. Then we should divide. So basically we would like to get to know how many milliamperes we will have for 1 degree of the Celsius. So in that case, we would like to divide whole range of the current to the whole range of the temperature which we use. So it should be multiplied by the temperature, measured temperature, right, that we have, and after that we also should shift it to the value of current where we have our temperature 0 degrees. So basically this will be our measured value. So a lot of engineers has this formula. I don't remember it. I won't use it. For me, it's just easier knowing all that range is just to find out how to calculate them. Again, so in that case, what we will have 16 multiplied by the temperature, which is minimal for our process, multiplied by -5 divided by 200 degrees Celsius, and plus 8 milliamperes. So in that case, we will obtain 7.6 milliamperes. When you have, again, some notes, then you have found this equation. So basically, first of all, you should check is it right. So it's better to have some to set some H values. For example, let's try to set here if our temperature equals to minus 50 degrees, what value you will obtain. And if you obtain 4 milliamperes, that means that your equation works and you can continue. Always check, because this is the first mistake that I have during the exam. Student tries to find out dependency between two ranges. He or she provides some equation, but if I set just this maximal and this minimal value, and if I don't obtain the maximal and minimal value of this range, that means that something went wrong. Okay, then what will be the maximal value for the current of our process? It will be 16 multiplied by 140 divided by 200 plus 8, and we will obtain 19.2 milliamperes. So the next one, as you can see here, the real values for what can be obtained by our PLC is inside this range only, but still we should, because our span is much more huger, so we should use the whole span, because our input reacts on signal from 0 milliamperes to 20 milliamperes. That means that according to that, the smallest integer we will have 0, and the highest integer we will have 4095. So in that case, we also should provide some information. So in this case, what we have in this case, we have, for example, for current, we will have from 0 to 20 milliamperes, and for the number we will have from 0 to this value. So somehow we should first of all, we should check what will be value for our initial zero, because using that we can shift our signals any way we want. So always try to take as initial value 0, because from this point it is easier to shift all signals. Of course, we can take as an initial this one, but in this case it will be more complex. So let's find out what will be n if we have 0 degrees Celsius. Okay, we know that if temperature equals to 0, here we have 8 milliamperes. Again, what we have, 20 milliamperes is the whole this dimension, and for I, we would like to get to know what will be the n. So n will be equal in that case just the range for the whole range for the n divided by the whole range of the current multiplied by the current value. So it will be, yes?
It should be 496 actually, because range.
Yeah, yes. Okay. 0 is also
0 milliamperes.
Yeah. I should check what was the power.
412.
12.
96 actually.
Then 96.
Here it's correct. 95 is the last value, but the range is. No?
Okay. We have, yes, we have range is just one less.
Maybe
we have values, but the range is one less. Take a look at that. Okay. Here what we have, so we obtain that dependency. It's very easy to obtain that because basically all those values are from 0 to the maximum. They are not shifted. So in this case, n will be equal the range of n's divided by the range of the current multiplied by the value of the current. Actually, I have it here, but here I better provide the n mean. min and max. So actually this one is 100 or 1556, and this one is 3931. So basically we have answered that last question. We know at what range we will have our values, and it should be done actually, because in our laboratory we have such tubes, and some of my students are writing its master thesis on that, and we had a problem because physically our valve couldn't open. So basically, theoretically, our valve could open from 0 to 90 degrees, but practically it couldn't be. So in that case, our numbers here, they were not from 0, but from other values. And when we tried to control it, first of all, we had problems because we have tried in this range and nothing happened, so we couldn't understand what is going on. And after then we have found that physically our process just in this range, so we could continue with control actions. So it's better always to check out what are those values with our PLC is dealing with. So, and after that, so we have that values. Basically, this information we will already hear, but if we provide that information this way to our operator, so actually this person doesn't know will our factory blow or not, because this is just some abstract numbers. So basically we would like to have here some display with our temperature in degrees Celsius. So in that case we should provide one more and here we will have some troubles, because as you can see our temperature is here, but this number is there, so they are shifted. Temperature also shifted from 0. So in that case, first of all, it's better to get to know what will be the number then our temperature equals to 0. So so in that case, just let's find which number we have with 0 temperature. And this number will be 1638. So basically that means that our signal is shifted from 0 in order to find out the 0 temperature by this value. So actually that means that then we try to find out the dependency between temperature and our integers in PLC. We should provide always this shift. our measured value, and here again we just we should just provide how many, for example, degrees Celsius we will have for one integer. So in this case, we should divide the whole range of the temperature. It will be 200 degrees Celsius, and the whole range of our integers. So it will be 4095. So, in that case, let's check, do I have the right answer or not? So first of all, let's check if our temperature is the maximal one. So we should obtain 150 degrees Celsius. So in that case, if we said that 200 divided by this one and this one, so 5 minus 1000. Okay. Something wrong. Minus 38. Then multiplied by the 200 and divided by okay. I have missed something, and
Sorry, I have a question.
just a minute. I have
You should divide 200 by
By 4,
yeah.
minus exactly that.
Yes, of course. That's the problem, because we also shifted here, so our range will be not from 0. It will be from this initial value, and this
819.
this one. So in this case, minus this 819. So again, as I said, always always check always check that equation that you have obtained. So in that case, it should be divided by 3278. And as you can see, after our calculations, we obtain almost we always we lose in accuracy. So if we convert our signal, then we will have its maximal. It's not so good because there we have. Okay, and then we have another 200, and in this case 3,278, and will be, for example, for our process, then we take minimal value. For example, 100 of that 1,556 minus this value. So in this case we will obtain minus 4.99. So almost what we need. And then if instead of that we set maximal value for our process, which in this case will be this one, so we should obtain 140 degrees Celsius. So such a conversions definitely will be in, during your exam, because then you deal with sensors and equipment. So every engineer should do that in every project, especially when you are dealing with PLCs. So this is it for today. Thank you for your attention.
Question, is
Yes.
that text on open book or closed book?
You can use any materials. So because, as I said, here
Sorry?
we would like to obtain engineers. So engineers should use, could use any tool it has.
Any material available to solve it?
Basically yes, but in every case we have some limits. So for you, those limits will be your neighbor and social networks.
Yes, okay.